Rachel and Marcus. Oh my gosh. Okay, that's enough singing. All right, this is the second half of 6-1. Hopefully these notes don't go too long. But I'm going to start us off, before we jump into these examples, 1 through 5. Before we jump into those examples, let's go and do some like easy ones just to get our brains refocused, okay? So, the formula for finding an antiderivative is 1 over, go.
N plus 1 x n plus 1.
N plus 1, okay? So, if you have like, let's say x to the 5th power, and I'm finding the antiderivative.
What is n in this situation?
N is the exponent.
The exponent in the previous.
So it would be 1 over
5 plus 1.
which
so
is 6.
1
X
over
to
5
the
x to the 6.
1.
x to the 6th. That is your antiderivative.
Wait, can you slow down?
1 over 6 x to the 6th. Got it?
No, I didn't
So
get
if
that
you
at
take
all.
Okay, we're gonna do another
that
one.
you get x to the 5th.
No.
X to
I
the
didn't get that
14th power. Okay,
1
go.
Over
1
15,
over.
X
Add
to
1.
The 15th.
1 over 15. X to the 15th.
Not even close.
We do
Now
one
do-
where it has like the 3 in
Yep,
front.
we're gonna do that
Do-
next.
do-
Wait,
Okay,
I
we're getting
didn't
Emma
even-
on board. Okay, Emma, do you see
I
the
know,
pattern?
No, I don't.
Okay.
I don't.
When she
5th
puts
power.
it up there,
That's all you're looking at. It's the 5th
Okay,
power.
fifth
Okay,
power.
add 1.
Thank you.
6.
6. 1 over 6.
1 over 6.
X to the 6th.
How do I do x to the 6?
That's it.
Oh, n plus
That's the
1.
antiderivative. Yep, right? Okay, if n is 14, add
1 over
1.
15, x to
Can
the
we do a
15.
Okay,
negative
let's
one
do one
too?
more. X to the 101st power. 1 over. 102. X to the
102.
You got it. Okay, now let's do some hard ones. So let's say we have 4x to the 3rd power.
How do
Okay.
we implement the 4?
Okay,
in
now
this?
just wait. So do just the x to the 3rd power part, right? So if I do just the x to the 3rd power, just focus on that. It would be 1/4 x to the 4th power, right?
Yes.
Okay, I'm going to add the 4 in there.
So
And I'm going to take 4 times the 1/4. Which
but we
would
have
just
to do
be?
so 1x to the 4th. But
So x to the 4th
plus c, right?
plus c, technically, yes. All of
On
these
all
should
of
have
these?
technically plus c.
Oh,
Right? All of these should technically have plus c. We'll do those when we do your homework assignment, okay? So let's do another one. Let's say we have 2x to the 3rd power. Okay, we're finding the antiderivative. All right, so we would have 1/4 x to the 4th power, but I have to multiply that by 2,
So
right?
1/2 x to the 4th.
So 1/4 times 2,
Half
1/2
x to the
x to the 4th plus c, right? Okay, let's do one more. Let's do like 5x to the 7th power. I think this was one we already did, right?
Yes.
Okay, so x to the 7th would be 1 over 8 x to the 8th power. But then we take it times 5.
5/8.
So 5/8 x to the 8th power.
X to
Got
the
it? All right.
Woohoo.
Okay.
I know
All
that.
right. Let's go up and do. We talked yesterday about number 5. Some of you guys have number 5 already done, but let's walk through this one together if we have not already done. So 3x to the 4th power. Let's do this one together, right?
Where is this?
Okay. So this is 1/4. This is on the back side of 6-1. Back side of 6-1 notes right here. Okay. So we have 1/4 x. No,
1/5.
excuse me. 1/5. Bleh. 1/5 x to the 5th power, but we got to take it times 3. So that will become
3/5 x to
3/5 x to the 5th power. Okay. Minus
5/3
1/3 x to the 3rd power times 5, so 5/3
x to the 3rd
x to the 3rd. Okay.
Wait, well, why
Plus
is that
plus this guy right here
1/2
will be 1/2
x squared.
x squared. That one we don't have to multiply by any number because he's already 1 in front, so 1/2 x squared. Then plus c. Okay. Now we can check our answer by taking the derivative.
What
if
did
we
the
want.
dx mean again?
dx just means we're taking the antiderivative with respect to x. So
Okay.
I wouldn't really put too much focus on that, but there's that. Okay, ready?
Sounds good.
All right, let's do the one right above that. Let's do number 4. We'll work backwards, okay? Now, ooh, this is kind of tricky. This is kind of weird. It's supposed to be easy, but we have your integral and we have our dx. What lives here?
1.
C.
1,
1
okay?
and C. Yes.
1, which is a constant technically, right? Okay, so what is the antiderivative of 1?
0.
X.
That's the derivative. The derivative of 1
One.
is 0. What's
It's
the
C,
antiderivative?
C.
No,
X.
0.
no,
X.
x, right? What do you take the derivative of to get 1? Just x, right? Okay, plus c. All right,
Oh, wait, why do I kind of know how to do this now?
got it?
So that said
Absolutely
5. That's
Good.
like 5 though.
No.
Okay.
5x.
All right, also,
Where did the D
Okay.
come from? What is the D?
The
The
dx is just saying you're taking the antiderivative of
with
that.
respect to x.
So don't put
okay,
too much
so
focus on
here we
that.
go. Ready? Here's what this would mean, right? Let's say instead this would say dz. Do you know what my antiderivative would be then?
Of respect
Z
to
plus
Z.
C. It's just telling you what your variable is named, right?
The derivative of this variable.
The water in the water fountain's good today.
Okay. So,
what
whatever.
If it was
Bueno.
3dx.
Okay, all right. What if it was 3dx?
If it was 3D, then it would
3dx.
be
What do you
multiple
take the
dimensions,
derivative
so it's
of to
3D.
get 3?
Wait,
3x.
can you take the
Right?
derivative of a third dimensional
Now,
object?
If you want to think about it this way, Jake.
But wouldn't it be
Hold on.
3 up top? X
I bet math gets really hard once you're at the
Plus
third dimension.
Because you take the derivative, it's 3x.
Aren't we in the third dimension?
No.
Everything is 3D.
Okay, think of it this way. All right, everybody listen to this.
Math is not.
Okay, so you don't have to think about it. Okay, if we're taking the antiderivative of 3, everybody listen to this. Antiderivative of 3. 3 with an exponent or 3
Well,
with an
your
x,
calculator.
this is like 3x to the 0 power,
Okay.
right? That's what 3 is, 3x to the 0 power, right? If I take the antiderivative and you add 1 to your exponent, this would be 1 over 0 plus 1, x to the 0 plus 1 with the 3 there, right? Do you see how that works?
So
1 over n plus 1, x to the n plus 1, right? So if it's x to the 0 power to start with, this will be 1 over 1 times 3, which is 3, and this is just x. Do you see how that works?
Yeah.
So anytime you have a constant, it's like x to the 0 power, and you're adding an exponent on the end of it, right? Like adding to x to the first power. So if that helps you think about it that way, you can. Otherwise, like, just think, what would I take the derivative of to get 3? And it's 3x plus c. Got it? Okay, are we good to that point? Let's do some harder ones. So let's go to this guy right
Oh,
here.
yeah.
All right, here we go. Let's do this guy. 1 over x to the third power. This is where it gets hard. This is where you have to pay attention. Boys, are you listening?
I got it. Yours
Okay.
is longer.
1 over x to the third power. We're going to rewrite him first. And I'm going to do my integral symbol. And instead of 1 over x to the third power, I'm going to say x to the
Negative third.
negative third dx.
That's right,
Okay? I'm just rewriting him. He's moved to the top. He's x to the negative third power. Any questions about that?
1
Okay.
over negative
So-
2.
1 over negative 2.
1
x to the
over
negative
negative 3 plus 1, which is negative 2. You said x to the negative 3 plus 1 power.
Do we
right?
have to
Plus C.
do we have to do the stuff?
What?
Like flip with the negative.
Okay,
I
so
don't wanna do
we're to this point. Do you see where we're to this
that.
point?
Yes, I have
So
that.
this is negative 1/2, right? Or 1 over negative 2. X to the negative second power plus c. And I'm going to fix him.
No, I don't want to fix
Yeah, because x to the negative 2 power, x to the negative 2 power is going to go back down to the bottom. So this is
Oh.
negative 1 over
negative.
Do we really want to
2x
fix it?
squared plus c, right?
Oh, why doesn't the negatives go away?
What do you mean?
Negative 2.
This negative goes away, but this is not an exponent. That just is tacked onto the front.
I don't like
Oh.
So it's only when you have a negative exponent that he goes away. So this is my antiderivative. You see how that works?
So what do you do?
Okay.
Go to the
Okay,
square root
just
one.
wait. We're gonna do that one next. Okay. Anybody have any questions about that?
It's so ugly.
X to the negative third power. When you add, it actually becomes negative 2. That's the confusing part. Like, so, whatever. Okay? All right, let's go to this one. This one is another tricky one. This is x, the square root of x. Okay? The square root of x, if I rewrite him, is x to the 1/2 power. That's the first thing you're going to do. We haven't taken the antiderivative yet. He is just x to the 1/2 power. Okay? Write that down. X to the 1/2 power. That's what the square root of x is. X to the 1/2 power. Got it? Okay. I'm gonna write out all of the work for the rule. Okay. So I do 1 over n plus 1. What is n? 1/2 plus 1. I'm just gonna write it like that. 1 over 1/2 plus 1. X to the 1/2 plus 1. Got it? And then plus c. We're gonna fix him. Okay. Do you see 1 over n plus 1 x to the n plus 1? I just did all that stuff, right? What is 1/2 plus 1? This would be like 1/2 plus
4/3.
2 over 2.
4/3.
Would be 3 over 2, right?
Whatever. Shut up.
Okay.
Or whatever, guys. Shut up.
Okay.
Sometimes we.
1 as a common denominator would be 2 over 2, right?
Oh,
1/2
it's
plus 1.
I'm doing this one.
Okay,
That's
okay,
a
sure.
third.
Okay.
Okay.
So, all right, so we're not going to do any decimals. So this guy would be 3 over 2. What is 1 divided by 3 over 2?
I don't know what 3 is.
Flip it. 1 divided by 3 over 2 is
2/3.
2 over 3, right?
Wait,
One-
I just got so lost.
Okay, all right, do you see where we get 3 over 2?
I see that.
Okay,
Now we have 1
so we
over
flip
3
it to
over
the
2.
top, and then it becomes 1 times 2 over 3, which is just 2 over 3, right? So
Nice.
1 divided by 3 over 2 is 2 over 3. X to the, what's 1/2 plus 1 again?
1.5.
3 over 2 power plus c, right? Okay, last thing I'm gonna do, this is 2/3. The 3/2 power is okay, but this actually means the square root of x cubed.
But we don't have to
Plus
do that,
C.
do we?
Oh, I thought it was the cubic root
Can we
of
just
x
not do
squared.
that?
Nope. The 2 is the root, right? Because the square root of x means to the 1/2 power. The 2's on the bottom.
Can we just not
Right.
do that though?
We'll see.
I made a mess with
Okay,
Well, I don't know
we'll
if I did
see.
my homework.
All right. Here we go. Let's do the last one. This is more practice with the fractions exponents. Okay, here we go. You ready for this one? Okay, ready, set, this integral. Here we go. We got an integral and we've got x plus 1, right? If I move this x to the 1/2 power to the top, this becomes x to the negative 1/2 power. Do you see what I just did?
No.
Dx, okay? On the bottom, that's x to the 1/2 power. I'm moving to the top and it's x to the negative 1/2 power, right? Do you see how that works? Okay, we're gonna fix it. Ready? This is kind of a tough problem. All right, we're going to distribute this x through because there's no product rule for antiderivative, right? This would be a product rule 1. There's no product rule for antiderivative. Okay, so I'm going to multiply this through. This is x to the first power and x to the negative 1/2 power. Okay, so what is x to the first power combined with x to the negative 1/2 power? Just x to the positive 1/2 power, right? We add the exponents. So 1 and negative 1/2 is positive 1/2. Got it? Okay. Plus, what's 1 times x to the negative 1/2? X to the negative 1/2. Okay.
And then they cancel out.
Nope, we can't do that.
Why not?
Nope.
Why not?
Because they only cancel if like these numbers in front are the same.
They are the same.
No, they're not. No, they're not. Or like opposite each other. X to the 1/2. This is like saying the square root of x plus 1 over the square root of x. That's what he's saying. We can't add this together. I don't want to do that. Okay. Good. There's what we've got. Okay, now we have to take the antiderivative. I'm going to get rid of some of this stuff over here. Okay, because I'm running out of space. You can write off to the side over here, but I'm going to make it like all condensed in this area. All right, so we've got to take the antiderivative. Are you still following? All right, I'm going to start with just x to the 1/2 power. Okay, I do 1 over n plus 1. What's n? 1/2 plus 1, right? 1 over 1/2 plus 1, x to the 1/2 plus 1, right? That's what he looks like, okay? All right, then I'm going to do the second piece. So plus, I'm going to do this one. 1 over n plus 1. What's n? Negative 1/2 plus 1. X to the negative 1/2 plus 1. Got it? We see how that works? Okay, then we'll have plus c on the end here. All right, so we've got this going on. I'm circling it just so that you can see it, right? There it is. Now we're going to fix it, okay? What is 1/2 plus 1? Or 1/2 plus 2 over 2? This is 3 over 2, right? What's 1 over 3 over 2?
1/2.
No, what's 1 over 3 over 2?
2/3.
Is 2/3. X
Oh.
to the, what's 1/2 plus 1?
3 over 2.
3 over 2. Do you see how that works?
1/2.
2/3 x to the 3/2 power, okay?
Yep.
All right, plus, what's negative 1/2 plus 1?
0.5.
Is positive
So
1/2.
1/2.
What's 1 divided by 1/2?
2.
2. X to the, what's negative 1/2 plus 1?
1/2.
1/2. And we're going to go plus c, and we're not going to switch them back. We're going to leave them like that, okay?
Jeez Louis.
Jeez Louise. That is what he is. Got it?
So I did 5 and 6 wrong.
Okay.
So on number 5.
There he is.
You
There
have
he
to
is.
multiply or through. You have to flip it up and then multiply.
Just wait. We'll get to that. We'll get to that. Just wait.
So
Okay?
tired.
Are we good to go?
I'm so sore.
There's those 5 problems, okay? It gets easier the more you do it, I promise. All right, here we go.
I'm sore.
Last question.
Like some-
Last question. We talked before about like when we talked yesterday about how you find the 200, right? Like if you're working from velocity back to the position equation, how do you find that C is actually 200, right?
They tell you.
Okay, they're going to give you stuff, okay? So, on here, if we are taking the antiderivative of this guy, right? Let's work backwards. They give us the answer. So, but let's do it ourselves. So, this guy right here, 3x squared, would be 1/3 x to the 3rd power, but I take him times 3, right? And that is just x to the 3rd power. That's how they get that, right? What's the antiderivative of negative 1? What do you
X.
take the derivative of to get negative 1?
X.
Negative x, right? And then I need plus c on the end there. So this is my antiderivative. Got it?
Yep.
That's my antiderivative. Now, I want to know what c is like what the value of C is. Like maybe it's 4, maybe it's -7. I don't know. I want to know. They are telling me that I want this antiderivative, but I want it to go specifically through the point 2 comma 4, right? So what I have right here, this is my derivative, my antiderivative, and I have y equals x to the third minus x plus c. I'm going to incorporate a y coordinate in there, right? They called it f of x with a capital F, meaning the antiderivative, all right? Now to find c, all I do is plug 2, 4 in, right, for x and y. So I can figure out in particular what number is c actually. I'm going to plug 4 in here, I'm going to plug 2 in here, 2 in here. So 4 equals 8 minus 2 plus c. Okay, 8 minus 2 is 6. Okay, then what?
-2.
Minus 6, so -2. C equals -2. So final answer is actually the particular solution. I called it the specific solution yesterday. My specific solution is that the antiderivative is f of x, or you can call it y, I don't care, I'm not going to be picky, x cubed minus x minus 2. This is the particular original equation that goes through the point 2, 4 that has a derivative of this, right? Okay, does that make sense? So if you're trying to find c in particular, like what is that number c? Like c is a number, right? C is a constant. If I want to find particularly what that c value is, I just plug the number in. Got it?
Is that what it's wanting us to do on number 7?
Is that what it's wanting us to do on number 7? Yes.
What is the dx dy?
That's just saying, that's another way of saying the derivative of something.
Okay.
Right? Okay? So,
So you plug
there
in.
you go.
So you find that, and
Okay?
you set that equal to the y coordinate, and you plug in.
So
the
the
x coordinate.
point that they're giving me is 1, 1. It doesn't say that in
So
the
you
thing
just
at the
plug
top.
in 1 for x
And 1 for y. To
to
find
find
c.
c.
This is geometry.
Okay?
When are we ever gonna use this?
You just wait.
The ACT.
This won't even be on the
Hey,
NCT.
so 7, like that one.
What?
2x minus 1. That is not the antiderivative.
They're saying
No.
this is the derivative. The derivative is this. I want the original.
Is the
So I have to go back.
antiderivative x squared minus x plus c?
Yes.
I can't
X squared minus x plus c.
begin to
Can we
like.
do
I
like
said that.
in my head.
What?
Can we do 5 and 6?
I don't know. I just.
I
it
agree.
Makes it so confusing
No,
the way
not
they
5
write
and
it
6.
down.
2 and 6.
Okay, so this one.
You don't,
Which one?
What?
2 is easy.
5 and 6?
Really?
Look at 6.
2 is easy. Except I bet you did 2 wrong. Did you move the 2 up to the top with the x cube?
I bet you did 2 wrong.
Because you shouldn't. By the way, number 2. We'll talk about number
Should
2
be
real quick.
1/2 x.
Should be 1/2 x to the -3 power. The 2 stays down. The x to the third is the only thing that comes up. Okay, now I'll take the antiderivative. There you go.
So it's
Okay.
Can we do 5?
So 1/4 x.
Six is
No,
easy.
no, 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 no.
6 is
When
easy.
you add to -3 is
That
-2.
one's not.
So -2. So -1/4 is up front to the negative.
Is that what you said? -1/4?
X to the 1/4.
Okay.
Or to the
X to the -2 power.
-2.
Yeah.
Right. So
Yeah.
What do you do on 8? Use upper and lower
Don't.
sums?
That's 6-2. We haven't gotten to that part yet.
Oh,
So just do 1 through 7.
Wait, I just
For
need to know how to do
homework.
2 and 5 then.
I
2.
just
I
did
already got.
2.
I got 2 ready to go for you.
It's
'Kay.
1/2
When
x.
you no. When you move the x to the third power up to the top, it's 1/2 x to the -3.
Okay.
Now
Now do the
find
thing.
the antiderivative. So do the rule.
So you're doing so it's 1 over -2.
Yep.
But then you have to do that times half, so
Yep.
1 over -4.
Where did you get 1 over -2 at?
X to the,
N plus 1.
Negative
-3
2.
plus 1 is -2.
oh, so it's just
Is it 1
Negative-
over 8 x to the 4th?
No, because when you add to -3, it becomes -2.
Oh, I completely
Yep,
forgot
yep,
that was
Yep.
-3.
Yep.
so it's gonna be 1
Otherwise, you would be right. You're doing the right
negative
process.
1/4 x to the -2 power plus c.
Yes, but move your x to the -2 power back down to the bottom. So 1 over -4x squared.
1 over -4x squared. Okay, then 5.
Okay, all right, let's go through 5.
This is my last
Wait,
problem.
can I have 2 more seconds
Sure.
on it too?
Sure.
What is it? 1 over 4x squared?
Yeah.
This is so
1/2 times 1/2 is
1/4.
1/4.
How
So 1/4 x.
And it should be negative,
Negative.
How does this
Right,
even
negative
become
1/4.
a thing?
or
This
one
is-
over negative 4.
So negative 1/4 x squared plus c.
Is the x squared on the top or underneath?
I have it to the side.
It should be underneath,
So
because it should be x to the minus 2 power on top, and then you move it back down.
Oh, I see. Okay.
Alright,
genuine question.
number
Yes, sir.
5.
What study uses this? Like what actually uses anti-gravity?
So we'll be doing here next, we'll be doing area under a curve, and we use antiderivatives for that.
Why?
You'll see, just wait, we gotta get the rules down first. Okay, number 5, should we do number 5?
Yeah.
Okay, what are you gonna do on number 5? First and foremost, this is how much?
1/2.
X to the 1/2, right?
Negative.
Then, when I move him to the top, he is actually x to the negative 1/2, right? Rewritten, that's what he looks like. Got it? Okay, this is where you're gonna get stuck. We have to multiply him through for all of these, okay? When you multiply, do you add or multiply the exponents?
Well,
Add.
You
multiply.
add the exponents, okay? So, when I multiply him through, okay, I haven't even taken the antiderivative yet, but what is x squared and x to the minus 1/2?
X to the negative 1.
No,
To
You're
the
multiplying.
half.
you're multiplying. You wanna add the exponents.
Oh,
What?
3.
2 and minus 1/2. 2 and minus 1/2 is 3 over 2, right? Is 1/2. 2 and minus 1/2
I
is
guess.
1/2, right? Okay. All right. This is x to the first power. Got it? Okay. So x to the first power and x to the minus 1/2 power.
X to the 1/2.
X to the 1/2 power. Got it? Okay. Plus, what's 1 times x to the minus 1/2 power? Just x to the minus 1/2 power. And I've got that, and I've got dx, and now I have to actually find the antiderivative next.
Okay.
Okay.
So, 1 over
So 1 over, what's your n?
3 over 2
3
plus
over 2
1.
plus 1, write it all out. X to the 3 over 2 plus 1. Alright, that's your first
Yes.
term. Okay?
Then we have,
Should we finish solving that one?
sure.
Let's do that one.
So we
What
have
is 3 over 2 plus 1?
5 over 2.
This is 5 over 2. Okay?
So it's 2 over 5
So
x.
it would end up being 2 over 5, right? 1 over 5 over 2 is 2 over 5. X to the 5 over 2, right?
Yes.
Because 3 halves plus 1 is 5
Then
over 2.
we have the next
So
one.
my first term is completely done. He's done. All right, now we have the next one. All right, so plus x to the 1/2 power is 1 over n plus
The
1.
same
What's
thing
n?
we did. It's half.
1/2 plus 1. X to
X
the 1/2 plus 1.
1/2 plus 1. And then
Alright.
you're gonna have to flip
What is 1/2 plus 1?
3 over 2.
3 over 2.
2
So this
over
is,
3 x to the 3 over 2.
are we getting it? Kind of ish. Okay. All right, this next one. I'm running out of room on this next one. This guy,
It's
1
gonna be
over
negative half plus
negative
1.
1/2
so
plus
it's gonna
1.
be half.
X to the negative 1/2 plus 1.
So it's
okay.
gonna be negative.
So this 1/2 plus 1
half.
is 1/2. What's
2
1
over
divided by
2,
1/2?
so 2.
2. X to the,
3 over 2.
what's negative 1/2 plus 1?
Oh shoot.
To the 1/2 power.
To the 1/2 power. And then,
Put him above.
Let's see. nothing should go into the bottom because no negative exponents. So if you get to that point and you leave your answer like that, I will accept it. Technically, this is 2/5 the square root of x to the 5th plus 2/3 square root of x cubed plus 2 square root of x plus c. That's technically what he is, okay? So if you want to write it like that, that's fine. If you get it to just that fractional exponent, that's fine too, okay? Good, good? Icky stuff.
Can we look
6.
at 6?
Should we look at 6? Sure.
Yeah, I
Okay.
don't know if I can do number 5 on my own.
Sure, that's fine. We'll get you to the point where you can, okay? Y squared is fine, but this is y to the 1/2 power, okay? And I'm multiplying those together. When you're multiplying those together, what do you do with the exponents? Add them, okay? So what's 2 and 1/2?
1.
No,
It's just-
you're
it's
multiplying.
just 1.
You're multiplying.
Just 1.
No, you're multiplying.
5 over 2.
1.
5 over 2. It's 2.5, which is
Oh,
5 over 2,
yeah.
right? You're adding the exponents, right? You're not multiplying the exponents. You're multiplying the y's, which means you add the exponents. So that's what he looks like when I put those two together. Now we have to find the antiderivative, okay? So, antiderivative, 1 over n plus 1. What's n?
5
5 over 2 plus 1. Y to the 5 over 2 plus 1. Okay, let's figure out what's 5 over 2 plus 1.
7 over 2.
7 over 2. Okay, so this guy will be
2 over 7.
2 over 7.
Y.
Y to the
7 over 2.
7 over 2
Plus C.
plus C.
2 over 7.
You see how that
one
works?
was a lot easier than I thought it was.
Yeah, that's not too bad. It gets easier. Every single time you do one more of these, it gets easier every time. You get more used to seeing the pattern, like, because the exponent and the fraction in front should be exactly the same, but flipped, unless you have a number in front of it to start with, right? So anyway, okay? 5 and 6, there you go. Do the rest of them. 1.
Jake.
This is x to the
Jake.
1/3. Okay? 1 over n plus 1. X to the n plus 1.
3 over 4 x to the.
Yes.
Is 1.
Whatever
3
you
over
just said.
4x
Yes, I heard you. Yep, yep. Yep.
Oh, plus. Why does
Huh?
Kansas City
I'm
keep
just
calling
gonna
me?
sleep in Monday.
Okay, good. All right, I'll help you individually if you have questions, or I'll come look at whatever you want. Okay, but there's that. All right, goodbye, Rach and Mark.